Okay, this is the lecture video for MAT 1100 Lesson 1.2. And in this lesson, we're going to be looking at how to combine like terms. So we're going to work on the skill of identifying in an algebraic expression which terms are considered alike and which ones are unlike. Because the terms that are like terms are the ones that you can combine. So right here in this first box, we see an example of like terms and unlike terms. Notice that these are considered like terms because they have the same variable with the same powers. These have the same variable with the same powers. It does not matter whether the coefficients match or not. In fact, these don't. But as long as they have the same variables, the same letters in each one, so both of these have an x, both of these have a y, and notice that the powers on the x's are the same, powers on the y's are the same. Likewise for this fourth example, both of them have an x with a power of 2. Both have a y with a power of 1. So those are considered like terms. Anytime they are like terms, they can be combined when asked to do so. In this last example, these are both contain an x with a power of 1, so those are like terms. And then you have some examples of unlike terms. These are the kind of terms that cannot be combined. So notice that in these two terms, one has an x, one has a y, which makes them unlike terms. Here, they both have the same variable, but the powers aren't the same. So those are unlike terms. They must have the same variables, and those variables must have the same powers. Okay, in this example, they both have an x, so that's good with the same power, but then they differ on the second variable that they each have. So they have unlike variables, therefore they're unlike terms. Here, they both have an x, but different powers. Both have a y, but different powers. So these are unlike terms. And here they don't even have the same variable. So just a few examples, various examples of like and unlike terms. And now we get to the kind of problems where you're being asked to actually combine like terms, which would require you to first identify what terms are like and what terms are unlike. So in this first example, notice that you have a 2x, so you just look for anything else that has an x to the first degree, and you have two of those terms here. So once you see that they have the same variable, just copy that common variable and add up the coefficients. Combine the coefficients. Sometimes that's going to require you to add, sometimes it's going to require you to subtract when you're combining the coefficients, because sometimes one of them will be positive and one of them will be negative. So if that's the case, you'll subtract, but if they're both the same sign, you'll add them. So 2 plus 4, just so you can put that in your calculator if you want, positive 2 plus 4, and you would get 6. Okay, you might want to cross them out as you get done combining them so that you don't accidentally combine them with something else. Next, we have a 3y, so we're looking for anything with a y to the first to a power of 1. So that would be right down here. We have a negative 5y and a positive 5y. Again, as soon as you see they have the same variable and power, copy that variable. That never changes. The only thing that's going to change is the coefficient because you're combining two coefficients. So it's 3 minus 5. It's negative 2. Okay, after that we have two constants that are left. So we have an 8 and we have a 7, and when you combine those, positive 8 plus 7, you get 15. And that's your final answer. Okay, if you'd like to copy that comment there, you can do so. Like terms contain the same variables raised to the same powers. On the next page, in example 2, under combining like terms, we have this example. Oops, I already did so. Just clean that up. Okay, so just so you can see it done from scratch, get rid of that work, and let's check this out. So when we go to do this particular problem, let's see, the very first term has an a to a power of 1 and a b to a power of 1. So anything that has these same two variables with the same powers, you're going to combine with this term. So we have this one with an a and a b to the first power, and we have this one with an a and a b to the first power. So let's go and try and add all those up. Again, as soon as you identify terms that are alike, copy the variables because you don't want to accidentally change those. The only things that you work with that will change are the coefficients. So right now you're looking at a 4, an 8, a positive 4, a positive 8, a positive 12, and you're going to combine those. So 4 plus 8 is 12, and then 12 plus 12 is 24. Then as far as the next terms go, and again, you could cancel them out just so you don't accidentally use them again. Next term is the a term, and you have an a to a power of 1 here, and then look throughout and see if there's anything else like that. There isn't, so just bring it down into the answer, maybe cross it off. Then the next term, the final and remaining term, is this term with a b to the first power. There are no other terms containing b, and therefore that's your final answer. Okay, so we combined 3 different terms that had an a and a b to the first power. The variables never change. You're just identifying which ones are alike and copying the letters that all of them have. And then the thing that changes is the coefficient. So that was the 4 plus 8 and the 12, that was 24. We had no other terms containing a, so we brought that one term down into the answer, and we had no other terms containing b, so we brought that one term down into the answer, and that resulted in this answer. Okay? Now we look at how do you add fractions when the denominators, these are the denominators, are not the same. So the shortcut that I can offer you is this. You need to get these denominators the same. So in order to figure out what they both should be, you can just look at these and multiply them. 10 times 3 is 30. That means your common denominator, when you go to add these fractions, is going to be 30. They have to have a common denominators. So denominators must be alike when you are either adding or subtracting fractions, and we have just made ours the same, and I'm giving you this simple shortcut of just multiplying them to get a common denominator. Then in order to get the numerators, I also have a shortcut for you. All you have to do is cross multiply. So go across the fractions like this, right across that plus sign. 3 times 3, that's going to be the numerator on the first fraction, and then cross multiply the other way. And you get a 40. That will be the numerator on the second fraction. And once you get the denominators to be alike, just like when you find like variables, you don't actually change the variables, you work with the coefficients. Well, when you're working with fractions, once you get these denominators to be alike, you do not change it. But what does change is the numerators because you're combining them through this addition sign. So 9 plus 40, 49. And that's not the only way to try and get like denominators, but it is the shortest and the quickest way to do it. Okay, let's try that again. Remember, first thing we need to figure out is what is the common denominator. You can do that by just multiplying the two denominators. And that's 10. We also want to pay attention as we're doing these problems to whether or not we can reduce. And in your calculator, you'll have a function on the calculator. We can discuss that in class if anybody does not know how to reduce on their calculator. In my calculator, I just hit math, enter, enter, but you're going to be using the TI-30, so there's a function on your calculator where you can reduce. Or you can reduce it by hand. This doesn't reduce, so that's the final answer. In this problem right here, I just found out that the common denominator is going to be 10. So I'm going to have two fractions separated by a minus sign. I'll be subtracting this time. Both of the denominators are going to be 10. And now I want to know what are the numerators once I get those denominators to be 10. So 4 times 2 is 8. That'll be my first numerator. And then 5 times 1 is 5. That'll always be my second denominator. Always go to the left first. Get that first denominator by going across the minus sign and up towards the left, in the left direction. Okay, then actually combine them. And when you combine them, remember, do not change the denominators once you get them to be alike. But instead, what you want to do is combine your numerators. That's those top numbers. So 8 take away 5. You're combining them through subtraction. Okay, one more time. Here in example 2, you see a denominator of 10 and a denominator of 8. You need them to be alike, so you're going to multiply these to get an 80. So each of your denominators will now have an 80 on the bottom. We're going to combine them through addition. And to get those numerators, we're going to go across and to the left first. That will be our first numerator. And then we're going to go across and to the right. And that'll be our second numerator. So there's our numerators now. We have two denominators of 80. We're going to combine these now through addition. The addition or the subtraction that you might be prompted to do in the problem, that happens at the top, not the bottom. You are not adding or subtracting anything at the bottom. You're just simply getting the denominators to be the same, and once you do get them to be the same, you copy that denominator, but then the combination that you do happens at the top. And this time, we're going to combine those numerators through addition. So 40 plus 40 is 80. Now this one you can actually reduce. 80 divided by itself is 1. You want to reduce if possible. Okay, and then we have one more example concerning combining fractions with unlike denominators. So let's try that one more time. So you had two addition problems, and this will be your second subtraction problem. Again, the whole concept of all four of those examples concerning fractions was to get the denominators to be the same. And you do that through multiplication. This time they're both going to be a 10. And then to be able to get the new numerators. Go across, cross multiply, up and to the left, and that'll be your first numerator. Cross multiply up and to the right. That'll be your second numerator. And then once you get those denominators to be the same, simply copy that common denominator, but then combine these numerators. Okay, only combine the numerators. So 5, and you're combining them through subtraction. So 5 minus 4. That cannot be reduced, and therefore that's your final answer. And they left space for you here, so I was really supposed to put it right in this box, but I just did it right there. I'll copy it into here. So that first fraction was 5 over 10. Let me write a little bit more clearly. Second fraction was 4 over 10, and the answer was 1 over 10. Okay, then we come here to an application type problem. And in this problem, we're looking at 3 dressers, and they each have a width. The first width is 4 feet. 6 inches, Then the width of this one is 3 feet 9 inches. And then the third width is 2 feet 10 inches. So we're going to combine all the feet, combine all the inches. Okay, so let's go ahead and add all the feet. So we have 4 feet. And again, this applies to combining like terms. We have 4 feet, 3 feet, and 2 feet that are all alike in the units that they bear. So when you add all these up, we have 4 plus 3 is 7. 7 plus 2 is 9. Then we have these units in the back, which have the same inches for all of them. So we're going to go 6 inches plus 9 inches plus 10 inches. And when we add those together, we have 6 and 9 is 15. 15 plus 10 is 25 inches. But then we want to combine the inches with the feet that we have. And notice that these are not like terms. So we have to make them like terms. So we want to convert this into feet. Convert the inches into feet. So what you can think about when you try to do that is, how many inches are there in a foot? There's 12 inches per foot. So inside of 25 inches, you could just figure out how many times does 12 divide into this. So 25 divided by 12, because every time you have 12 inches, you have another foot. So 12 times 2 is 24 with 1 inch left over, because these are the inches. Okay, so this 25 inches right here is an additional 2 feet, because 12 goes into here twice. So you get an additional 2 feet with 1 inch left over. Okay, so in the grand finale there on the answer, we're going to have 9 feet plus 2 feet 1 inch. So that your final answer ends up being 11 feet 1 inch. Okay, everything in that section has to do with combining like terms. Okay, and that is it for section 1.2.